Okay, so in this video, we're going to do a quick introduction to how you use Git. And specifically, we'll use the class GitHub repository. That's going to be something you may want to do anyway if you haven't yet. So here's the web page for the class repository. And there's a link on Canvas for this. You can go on GitHub, though, and look at any page. Any public repository has this clone or download link. So you could download a zip, but the problem then is you're not going to be able to actually have a live repo on your machine. You have to do some other stuff. So we're going to actually clone this repo. So I'm going to go into whatever directory I want to put this, and then I'm going to type git clone and then give it the URL of the repo. So now, if I look what's there, you can see all of these files, including the example C files we did the last 2 weeks. So this will actually be week 4. So I'm going to make a directory. And then if I go into that directory, now notice this is in the directory where I cloned the repo. Whoops, I did that in the wrong place. So now you'll see I have a local directory that's named the same as the repo. So now when I cd to that directory, and I can do git status, and that just tells me, hey, everything's up to date, which makes sense because I just cloned it. Now let me make that directory. So I'm going to write a C file here. And this is really just going to be just a hello world. So if I compile this, and run this, okay, so there's my code. Now if I do git status, now you'll see that I have untracked files. So let me go back to the root directory and do a git status, and you'll see it's week 4. Now if I do an ls-l on week 4, you'll see there's a.out and there's git test.c. Now I don't want to put this executable into my repo. So there's a file called gitignore at the root of the repository. And here you can see that star.out is listed in this file. Anything listed in this file will not be added to Git. So you'll notice also we see a swap file down here. But anyway, object files and different types of precompiled headers, shared objects, executables for several different architectures are listed. And those are things that we don't typically want to put there. So that's good. I want to exclude that, but I don't have to specifically exclude it here. Gitignore means that this a.out will be ignored. So I'm going to say git add week 4. Now notice here it said untracked files. Now if I do a git status, it says I have a change to be committed. So now I'm going to commit, and I'll say initial version. And if I do git status now, it says that my branch is the head of origin master, meaning I've pulled from GitHub. That's where the master repository is. So what I have locally is ahead of that, because if I go back to GitHub, you can see that week 4 isn't there. So now let me make a change here. Again, this is just a little toy program, but I just want to demonstrate that there's some code changes just so you can see how that works. And if I compile this, There we go. So now git status says that I've modified this, and I can see what I did by using the git diff command, and I can see that I've added these files. Okay, so I'm going to git commit -a to add the modified files, and -m to give a comment. Now, if you leave off the -m, it'll actually open up an editor for you, and you'll have to edit it and so forth. So usually that's VI, so make sure you know how to quit VI, or just use the -m command. And I don't have the global config set, but that's not a big deal here. So now, if I do git status, I'm ahead by 2 commits, so I'm going to push those to GitHub. And since this is my repro, it's going to let me do it, but I have to log in first. Notice I could pull it, or I could clone it without having credentials, but to actually make a change, it wants to make sure that it is me. So now it's loading these things, and if I go to GitHub now and reload, notice week 4 is there, and I can see that commit. And what's really nice about GitHub is, okay, with this commit, if you click on the name of the commit, notice it gives you a really nice graphic of what exactly changed. Okay, so this is a different machine. I was running that on a virtual machine. Here's a Cygwin instance where I have that particular repo checked out, but notice none of the changes are there. So I need to do a git pull, and that's going to bring in week 4 git test.c. Well, that's nice. So I'm going to make a change because I'm going to add a function here. Now, one thing you're noticing is on this machine, I have different settings for VI, unfortunately, and so that's causing trouble. And that's something that happens when you're working with different people working together. So we're sort of simulating that here. So here I've added this function, and then I'm going to add some stuff. Printf. So here I'm calling the function. Okay, again, more toy stuff. Okay, good. So now I have some extra stuff. And we're added this. Now, let's say over here, let me add some code. I'm going to add a comment. So I'll add a nice comment, and that's good. Notice that function is not there. So I'm going to git commit. And here I've added a comment. And then I'll do a push. And if I bring up our GitHub site, notice that changed, that commit's there. So I've pushed this commit, but the actual file name is not there, or the actual function I added, because I never actually committed or pushed this. So if I do git status, so that's modified. So I'm going to commit that. Okay, so now let me do a git push. So that's there. Okay, so notice failed to push because the remote contains work that you do not have locally. I don't have that comment here. So I need to do a git pull. And notice this did a merge. So I'm just going to say merge branch master, whatever. So that pulled in some stuff. Notice it put that comment there. It did a merge. It took the changes that were on the remote repo, merged them with what I have. So notice I have a comment and I have this extra code. And notice now I'm ahead by 2 commits because I have the commit that I did locally, but then I also have the commit that was the merge. So I'm going to push this. And we'll say that we're done with that for now. So if I reload this, you can see that this merge was the last thing done, and that merge, whoops, that's the wrong. I'm clicking on the URL, not the actual comment. There we go. So if I click on this, you can see it added that particular comment, and notice it added the function as well. So if I go into and look at the history of that file, I can see that I have the initial version, I added the for loop, I added a comment, and that was all done on the VM side. And then here I added the add function, and then before I could upload that add function to the remote repository, it had to do the merge. And so I can click on any of these and actually see what all changed. And here we're only doing one file, but if I did multiple files, you could see all of those changes. So if we look at the code examples repo, this is the one that I use that I keep track of all my class material. And so you can see that I have some where I synced with Spring 2020 class updates. I made some minor updates here. These are all different types of files. So if I go into the C file, and let's just take C, I think C3 is the one that has a lot of, no, C2 is the one that has a lot of stuff. And a lot of these, as I'm adding to this repo, I'm also creating videos. So you can see most of the things, most of the comments are sync with videos. So I can say, for example, click on this, and you'll see that here I made some changes to debug.c, and it'll show the changes. And I also made changes to more array pointer.c, changes to ragged string array.c, and so forth. And so this commit had multiple changes. And in practice, you don't necessarily want to do this. This is okay for me to do in this case because this is all mine. I'm not trying to communicate with other people. But typically, you want to try to have your commits be relatively small. So this has, you can see 300 additions and 375 deletions on 11 different files. So that was a pretty big change. Typically, you want them to be smaller than this. But again, this is just because this is my personal one. And I would recommend getting used to using Git and using it, for example, your projects. And I'll walk you through how to do that in another video. But for now, this is just sort of an overview of how Git works. And I would recommend pulling this repo or cloning this repo and also cloning the specific repo for your class this semester, and making sure you're, in addition to cloning it, on a regular basis, do a git pull so that you get the latest updates, because I make changes to these repos throughout the semester.